we are going to continue with our discussion of measurement of conductivity and molar conductivity of a solution. So let's get into the discussion of this measurement. There are two steps involved, of which very first step we are going to determine the cell constant, that is B. Alright, and for this determination we are using a conductivity cell with KCl solution. So here you have a conductivity cell which is filled up with KCl solution, and for this measurement we can use different concentrations of KCl. So it could be 1 molar or 0.1 molar or 0.001 molar KCl solution. Alright, now students, for these particular concentrations we have the conductivity values of KCl known to us. Alright, so the conductivity of KCl is known to us at various temperatures. So we could have KCl of 1 molar solution or 0.1 molar solution or 0.01 molar solution, which has a predetermined conductivity value. Alright, now here the resistance of KCl solution is determined by a Wheatstone bridge principle. Okay, so let us understand what exactly it is. Here you have AB, which is a uniform slide wire. Alright, the resistance, that is Rx, is a variable known resistance which is placed in one arm of a Wheatstone bridge. Alright, the other arm, here we have placed the conductivity cell dipped into a solution of KCl of unknown resistance. Okay, so precisely we are finding the resistance of KCl solution here. Alright, here we are using a detector, a current detector, which could be regarded as a headphone, and there is a sliding contact which is moving along AB. Alright, now students, the source of alternating current here is used to avoid the electrolysis of solution. Very important point. For the measurement of conductivity, we always use a source of alternating current rather than direct current, so that electrolysis of the solution could be avoided. Alright, so now getting into the working part, the sliding contact is moved along AB until no current flows, which is shown by the detector. Okay, and now let's say this balancing point is obtained at C, right? So here we consider the balancing point at C. So now we can consider that AC and BC are the balancing lengths of the wire. Alright, and R we are considering as the resistance of a KCl solution, which is unknown to us, right? And Rx is a known resistance. So according to the Wheatstone bridge principle, we can say that resistance of a solution upon resistance of the wire AC is equal to the Rx upon resistance of the wire BC. Alright, and we know that resistance is directly proportional to the length. So here we can consider that resistance AC is nothing but corresponding to its length, that is length AC. Similarly, resistance BC is corresponding to length BC. So we can say that resistance of a solution upon length AC is equal to Rx upon length BC. So we can say here that resistance of a solution is equal to Rx into length AC upon length BC. Through this particular equation, we can determine the resistance of a solution, and here we are using a KCl solution. Alright, now by measuring the lengths of AC and BC and obviously the known values of Rx, we can determine the resistance of a solution. Now here we have the equation K is equal to B upon R. Now for KCl we already know the value of K, right? So B here is nothing but K into R. So conductivity of a KCl solution is already known to us. We just now determine the value of resistance of this KCl solution. So through that we can calculate the cell constant. isn't it? So the very first step in the measurement of conductivity deals with determination of cell constant. Alright. The next step here is the determination of conductivity of a given solution. Alright. So now here we usually use a KCl solution. So now instead of this KCl solution, we are using a solution of unknown conductivity, right? So it is replaced by, this KCl solution is replaced by a given solution whose conductivity is to be determined. So we are using here the solution. Now, the given solution resistance is measured by Wheatstone bridge principle, which we have already described earlier, isn't it? So we determine the resistance of this solution. The conductivity of given solution is then calculated by the equation K is equal to B upon R. And we already know now the value of B, that is cell constant, and resistance we can determine for this particular solution, right? So considering these two values, that is B and R, we can determine the value of conductivity of unknown solution. I hope students you got a clear idea with respect to measurement of conductivity. Alright. Now, molar conductivity of a given solution, students, we have the mathematical expression as lambda is equal to K upon C. And if we know the concentration of the given solution, then we can also determine the molar conductivity of a given solution because we already determined its conductivity, right? So through this equation, we determine its molar conductivity as well. So I hope students, you got a clear idea with respect to this particular module. Thank you all.